When you're sitting on a beach surrounded by millions of grey pebbles, it can be quite easy just to not notice them anymore. But in fact, this beach is covered in stories of all different sorts if you only know how to look at them and work out what's going on. Hello again and welcome back to Aberystwyth. It's the closest point to this on the seaside to me in mid-Wales, so I come here quite a bit. But the beach here, you'll notice, is very, very grey. It's covered in millions of rocks like this. And the reason for that is the local rock. Over in the headland far over there, it's layers and layers of sandstone, like this, about so thick, fine bands going through it. But when you see it in outcrop, you find that it's not just layers of sandstone. Between them are layers of mudstone. It's very fine, it's very black, and it's very soft. So when that erodes, this basically disintegrates back into mud, and this stays as large blocks. So you end up with just masses and masses of sandstone. Which is a shame really, because both of these are equally interesting. This is a deep water deposit. It's from the Silurian period, about 430 million years ago, when this was a sea, the Welsh Basin, a long lost sea. It's since been squeezed out of existence by collision with Scotland and a new mountain range being formed. And in that sea, there were deposits of very, very fine mud, which were particles of mud that just drifted out into the ocean, sank down slowly onto the seafloor and built up, occasionally with fossils in, very, very slowly. So this might have been deposited in something like 10,000 years for all I know. It's slow. Interspersed with that though, there are layers of sand which wash down from the shallower water in the east. Slumps underwater which basically just followed the slopes down into the basin, and this might have been deposited in a few hours. A few hours, 10,000 years. Geology can be a little bit sort of unexpected sometimes. You'll also see large numbers of rocks, which everyone loves, like this. Same sort of thing, sandstone, mudstone with white bands going through it. And these are the sort of things that people notice and wonder about. And they actually have a very simple explanation. They're called veins. These ones happen to be quartz. And veins are what happen when rocks are slightly mangled. So if this is buried, for example, under a few kilometres more rock, and then you do something silly like crash into Scotland, then you end up with a mountain range being formed, the rocks get faulted, crunched around, folded, and cracks form. And along those cracks, you get hot water percolating. So this water is circulating at depth, the hot water rises up through these cracks. As it does so, it cools, and all the dissolved goodies inside the water start crystallising out. And in this case, those goodies are mostly quartz. If you go inland that way a bit, it also includes things like lead and silver. So, sort of thing that's worth knowing about. But veins, they're absolutely everywhere around here. Let's see what else we can find. Are you sitting comfortably?
No, not really. There are a lot of pebbles here.
Yeah, never mind, I'm going to start anyway. Once upon a time, a long way to the south of here, well, probably about 50 miles or so, there was a warm, shallow sea. It was a nice sheltered sea, and there were lots of animals growing on the seafloor amongst the mud. And some of those animals left behind them skeletons of calcium carbonate. Calcite, in fact. And those skeletons turned into this. This is a little bit of the Carboniferous limestone with corals. So at the time, this was a much warmer place, mainly because we were on the equator. And this was part of a lagoon in which there were large numbers of coral colonies, lots of other animals living amongst them. It was a reef from the Carboniferous. So we're here in Aberystwyth. as you can see, it's not very good reef country at the moment, but we do know that these rocks are exposed on the south coast of Wales, where you do get these fossils. And in Aberystwyth we have not only the sea bringing pebbles up along the coastline, we also have rivers bringing rocks in from inland, and we have glaciers in the past which have moved things all over the place. So you can end up with, on a beach like this, bits of rock from all sorts of areas within Wales and even further afield. So I think we should have a look at some. Occasionally, amongst all this grey, you find little red rocks. And this is something I particularly wanted to find today, particularly in light of another news story that I did a little video about. Have a look in the description. And what we have here is a coarse sandstone with a dark reddy purple colour, which is instantly recognisable to anyone who works around here in geology as the Old Red Sandstone. In Herefordshire they make walls and buildings out of it. There's lots of exposures around the south coast of Wales as well. And I particularly wanted this because this isn't just the Old Red. Because this is also a little bit of Old Yellow. That little round spot there. That's not what you expect from an Old Red Sandstone, presumably. But this is what happens when you have a bit of organic matter, say something like a bit of a plant root, for example, in these deposits which were laid down in rivers in the Devonian period, which has been buried in sand and it has had bacteria gradually decaying it, eating away at it and turning it into their food. And the way that these bacteria work are by oxidizing the organic matter. So when they do that, they need to move electrons around. That's what oxidation is. So they do that by reducing the surrounding iron-rich sandstone. So the oxidized iron, which is what gives it the red colour, has been reduced around where the bacteria were decaying this bit of organic material, and you're left with a reduction spot. So there's no fossil left in here yet, or anymore, but you can see where the fossil once was, or where the organic material once was, because other life has got in there and left evidence that it was there. And this is the sort of evidence that was being used recently to argue that we may have found traces of life on Mars. It's this sort of chemical reaction, or environmental chemical reaction, which is a result of potentially bacteria decaying something in situ. So that's not a bad one. But we do have traces of definite life, which is much more recent. So there are quite a lot of pebbles here which have holes in. And some are quite big holes, like this thing here has large rounded cavities in. And there's one there actually where the occupant is still inside it. These are blocks of limestone which animals have bored their way into. So in that case, in the case of these large ones, we're looking at a thing called a piddock. It's a bivalve, and they use acid and their little teeth on the side of their valves and on the edge of their shells to scrape away at the rock gradually over their lifespan as they grow into a block of limestone. This has since been mostly eroded away, but originally it might have been about that far into the rock. And of course they're getting bigger as they're going into the rock, and eventually they can't get out. Like that one in there where the shells are actually larger than the hole that they've gone in through, because it's grown in situ. And that's actually a good plan, because these bivalves don't want to get out. They want to sit there, stick their little siphons out through the hole, suck water in, take out all the juicy stuff, and that's their life, really. It also means, of course, that it's very difficult to get them out. If you were a hungry bird, for example, you'd have a problem with that one. Okay, there are also what look like little worm burrows, little wiggly, sinuous traces going through here, which are very different. And those probably are, in fact, worm burrows. made by sipunculin worms, which also use acid to etch into the surface. There's another video, if you check the description, on some fossil ones of these that we found recently in a Silurian nautiloid. But this is my favourite. I know it would be. But these ones are like a sort of string of pearls, a sort of chain of holes which are bored into this limestone pebble. And that was made by sponges. It's a thing called Entobia cateniformis. That's the name we give to the trace fossil that marks left by it. And there was a sponge, probably quite a large one, growing over the surface of this and etching its way in to leave this quite distinctive network of little borings behind it. Reason for this is that some of the sponge is inside the rock, so even if something comes along and grazes it, eats most of the sponge away, it can regrow because there's enough of it left inside. It's a neat little trick, really. I think we should all try it. So those borings are modern. They're technically, I guess, fossils in that the animal that made it isn't there anymore, so it's some sort of past life, but we don't know when this happened. It might have been thousands of years ago. It might have been last week. But that is about the limit of the modern side that we can get to. That's as young as we can get. But some of these pebbles are probably very, very old indeed. So this is a lovely one that we picked up. It's black, it's glassy, it really does look a bit like glass, almost like obsidian, and it's made of a similar material. This is what we call chert. It's a very fine-grained silica-rich rock made of effectively microcrystalline quartz. And a long, long time ago, in the Precambrian especially, chert formed very commonly from seawater. It's something that would just spontaneously crystallise because the concentration of silica was so high within seawaters that you have layers of chert forming over large areas. This all stopped when animals got going, and sponges in particular started extracting silica from the seawater to make their skeletons. So around the base of the Cambrian we see a loss of chert deposits. But could it really be that old? Well, there's another hint that it is as well, because this is full of little white lines. There are cracks going through the rock, we're full of crystals, probably quartz. It's going to be quartz, let's face it. And these are going in all directions through it, well, a couple of major directions, but this rock has had a hard time. It's been mangled, it's been fractured, it's been squeezed, and then crystals have grown within the cracks by hot water percolating through it. So this has been through probably something like a continental collision mountain building event. It's been absolutely mangled. And that's the sort of thing that doesn't happen very often. It probably happened to this one maybe in the Caledonian orogeny at the end of the Silurian, but more likely it's an even older deposit. The problem is, we don't know how this got here, because the sea is bringing pebbles up from the south, and there aren't any rocks like this to the south. The rivers are bringing pebbles from inland, and there aren't any rocks like this inland. There are, however, rocks that have come from the north, which are brought by glaciers. So during the last ice ages, or the last glaciation, because technically we're still in the ice age, there would have been pebbles brought from places like Anglesey, which is full of extremely old rocks and does include Precambrian cherts. So maybe this came with the ice from Anglesey. Or maybe it came with humans. Humans have a habit of putting large rocks in the bottom of ships to make sure that they balance in the water properly, and then dumping them in other parts of the world. So, for all I know, this could have come from Bolivia. There's also a bit of a mystery about this one. Same composition, it's basically silicon dioxide, but this one is very distinctive. It's called flint. And flint is Cretaceous in age. It comes from the little concretions, pebbles, effectively, that grow within the chalk. and it is exposed along the south coast of England and some of the east coast, and that's as near as you get flint to here. Naturally, it's difficult to see how this could be here. However, we do know that probably there was Cretaceous rock covering Wales at one time, because at the time that this was formed, the sea level was extremely high and Wales was probably underwater. The chalk was probably deposited over large parts of it, and the flint would have been there too. It's just that it's all been eroded away. There is nothing left of it exposed here. So possibly this is a relic of when there was a Cretaceous cover, and these things have been eroded out, left in deposits of sand in rivers, reworked, re-eroded again, deposited here, and eventually you end up with this last sort of trace of what might have been a Cretaceous rock layer that is no longer with us. Alternatively though, it's people again. Because flint has been used as a building stone. We walked past a couple of gardens which have lots of flint in there, it's gravel. It's probably something like that. It may even be much older people, much earlier ones, where they have been trading flint to make stone tools. Because there was a trade between southern England and most of the Mediterranean, where flint was so sought after for making stone tools that it travelled far and wide. It's just possible that some of these bits of flint were brought here after the Ice Age in the Stone Age. We'll probably never know though, so you can make up your own stories about that one. There are also, as you're wandering around, lots of nice speckly rocks. These are sort of things you take back and put on your rockery, although you're not allowed to, so don't. But what we've got here, very dark, fine-grained rocks, which contain a lot of little white bits in them. And some of these might be sandstones or whatever, but in many cases, you can actually see that there are square or rectangular little shapes in here. Quite sharply angled. Yeah, there's quite a lot of them. That's a nice little one there. Hopefully you can see that. Little sharply angled crystalline shapes, and that's because they're crystals. So this is a fine-grained rock full of large crystals that have not been washed around in rivers. They haven't been deposited as part of a mudstone or sandstone because they're still crystal shaped. They've not had their edges worn off and rounded. So you have something like that, you know immediately it's volcanic. That might be a surprise in Wales. We're going back quite a long way to get to this sort of age, but at the moment Wales is part of an extremely stable bit of the Earth crust where there are no volcanoes, and there haven't been for a good 50 million years. However, this sort of volcano was actually common in Wales in the Ordovician period. You go back to about 450 million years ago, and this was part of the Welsh Basin, an ancient sea, but which was, most of Wales was covered by water. And there was an ocean between us, our part of the little continent, and Scotland, which was the other side of the Iapetus Ocean. And that ocean was subducting underneath Wales, or underneath Avalonia. And as a result of that subduction, just like you get around the Pacific today, you get volcanoes. And there are quite a lot of them. So we live next to one of them in the middle of Wales, in Llandrindod. But there are also large volcanoes in South Wales and Pembrokeshire. Places like Strumble Head and Fishguard have huge volcanic deposits from the Ordovician period. And that's probably where these have come from. They've probably been washed up the coast by longshore drift, and you end up with little bits of ancient volcanoes deposited on a seaside town in Wales. Interesting when you know, isn't it? But then, sometimes you get things which look really rather interesting. Bright red, with lumps in, with bands of black material. To be honest, I'm not entirely sure what this is. It looks like jasper, which is a silica-rich slightly altered sediment that is normally found from deposits from the deep sea floor, from mid-ocean ridges, which have been altered, metamorphosed by hydrothermal fluids, hot water, and you end up with this sort of quite striking, vibrant rocks. So I'm going to have a really close look at these to try to work out what's going on, because I have no idea where you would get jasper in this area. Possibly also from Anglesey, because you do get bits of oceanic crust up there as well. So maybe these are little bits like this chert which have come down from the north and are probably very old. I mean, this, if it is that, it's probably 600 million years or so. Old enough. Alright, I might finish with this one. Here we have one whose origins are a little less mysterious. You see, to start with, that is not a rounded pebble. This hasn't been washing around on beaches for decades. In fact, it's probably been washing around for about a week. There was a storm quite recently. And it's a dark, grey, limey mudstone, and it's full of fossils. Particularly these large shells. These are things called productive brachiopods, and they are carboniferous. So the same age, more or less, as these lovely little corals we saw earlier. These are brachiopods that lived on the seafloor, resting with these curved shells onto a sort of muddy surface, and in some cases, you can just make out that one has got the two shells together. There's a very thin one on top of the heavy one below it. Hopefully that's come out. And this is again carboniferous. And there are large blocks of this just up there, which have been used to reinforce the harbour wall and the breakwaters. So that's humans again. We don't have to make a mess of geology. It's nice to prove yourself wrong sometimes, isn't it? Here is a nice lump of chert. And you can see it's got all the veins going through it, it's fractured, it's exactly like that lump we were looking at before. But this is in a massive block of the carboniferous limestone. In fact, there's another bit here. So the chert is in fact not Precambrian from Anglesey, it's carboniferous from wherever they got these blocks from. I think that'll about do it for this time, just as the sun's coming out. I've got other stuff to be trying this afternoon. Anyway, so if you enjoyed that, let me know and I can do some more. We can go to other places, because there are all sorts of areas where you get pebbles, each with their own rather interesting stories to tell. And next time you're at Aberystwyth or anywhere in the same sort of area or anywhere around the world, just stop and look at them and see what little stories you can make up from these rocks, because you can never run out of fascination when you start understanding what these rocks are telling you. It's like having a library at your feet. Try not to tread on it too much.